Welcome to the Oracle Coherence 12CR2 or the Coherence 12.2.1 video series. Hi, I'm Brian Oliver, an architect with the Oracle Coherence team. In this session, we'll be walking through the enhancements we've made to Oracle Coherence to support parameterized types, that is, generics. The agenda for this session is as follows. First, we'll take a look at how application developers like us would typically use interfaces, for example, name cache, prior to using Coherence 12.2.1. After that, we'll take a look at how application developers can use the new interfaces or name cache with parameterized types for example, keys and values. Lastly, we'll look at the options available for improving type safety and how backwards compatibility of these interfaces is ensured. So let's get started. Prior to Coherence 12.2.1, working with a name cache, say that used strings as keys and a person type as values, would look something like the following. Essentially, when you call get cache, you would ask for the name of the cache, in this case person. Maybe we'd then create a person object, then we'd put it in the sort of people cache, and then later at some point some other part of the application, in fact in a different process, may even ask, hey, get that person back using that key. The challenge with previous versions of Coherence is that when returning the type from the name cache, because name cache is essentially using just the object types, we would have to cast into the desired type. And of course, casting can be quite painful if you're doing a huge amount of it. Alternatively, if you're executing a query or aggregation, you'd also have to cast the result. And we've aimed to resolve this challenge. With Coherence 12.2.1, we can now use parameterized types with name caches, i.e. we can use generics, which technically makes them simpler and potentially safer to use. We'll talk about the safety bit shortly. So now we can actually declare a name cache with the desired types in Coherence 12.2.1. Nothing really radical about this, and we can also request that we can get a typed cache with the desired types that we want, and the example now is pretty much as before. We can create a person object, we can put a person object into the cache, but now, because we're using generics, we no longer have to perform any casting. And this is very, very helpful, not only for read operations, but also all our new aggregation options and queries, key sets, get values, and so on. So that should be it. I mean, all we've done is we've made name cache type safe with generics. Well, let's talk a little bit about type safety. While Java provides the ability for applications to use parameterized types, unfortunately due to runtime type erasure, this information is basically lost at runtime, or in fact it's unavailable at runtime. For single process applications, this is rarely a problem. Everything is contained within the process, the whole application is running in one place, it's compiled together, and so on. However, this poses a potential problem and a challenge in distributed systems where individual applications and deployments may actually be for different purposes, may have different versions, and you may not be able to assume that every deployment, every version is using the same types, or in fact using the same caches consistently. And this is exactly the sort of deployments where we see coherence used in large enterprises. So what would start out as almost a trivial, not really an issue in a single process application, as you start to scale out and as you start to have different applications connecting in or joining into your cluster, the chances of type inconsistency between those applications increases. Unfortunately, without type information being available at runtime, Coherence can't really assert or enforce the type consistency as you'd naturally expect, especially if you have different teams working on different applications, connecting or using the same cluster, sharing data. So we have to come up with a nice way or a clean way to allow application architects and developers to assert the types that they really, really want, either with very strong consistency or without so much consistency. So to help solve this challenge, Coherence 12.2.1 introduces a new cache factory method, allowing developers to specify how type safety is asserted, if at all, when using typed caches. The signature is pretty straightforward. It's very much like previous cache factory, existing cache factory methods. Instead of saying get cache, we say get typed cache. And in addition to providing the name, we provide the type assertion that we want to have applied at runtime. So this new type assertion interface is what we're now going to look at. To make things easy, what we've done, Coherence provides several static helper methods that are declared on the type assertion interface. These will help you define the intent in terms of what you want in terms of type safety. So when an application developer requires, for example, Java and Coherence to enforce that the types of a name cache match those within a cache specification, they use what we call with types. So in this case, we say I want to get a type cache called people, and I'm using the type assertion helper here called with types, and I'm saying that I want to make sure this cache has keys as strings and the person class as values. And Java effectively, and the compiler enforces that the name cache string person, these things are assignable. If the types in the type assertion aren't assignable, so these things don't match to over here, then you'll get a compile error. If these don't match in your cache configuration, which we'll talk about in a second, then you can get a runtime exception. So together these two checks make it much harder, although unfortunately not completely impossible, for developers to use caches in an inconsistent manner across applications, at least accidentally. So for Coherence to perform strong type checking, you really need to configure the types in your cache configuration files. So this is achieved by specifying the new optional key type and value type within the cache mapping. For example, for our people cache, we wanted the key types to be strings and the value types to be person. So what happens when an application attempts to assign the same name cache to variables that are mismatched or using misconfigured types? Well, as I mentioned, in this case, I'm saying, hey, I want to use integer keys and a person value. Java will actually issue a compiler that these two things aren't assignable, which is precisely what we want. However, let's say that they are assignable, but our configuration doesn't match. Well, in this case, Coherence will actually throw a runtime error. And this prevents you from putting invalid types in this cache. Now, of course, you can probably circumvent this if you're familiar with generics and the type system, but it's pretty hard now to actually make these sorts of mistakes. So when a developer actually wants to use generics but really doesn't want the compile time safety, and instead just wants Coherence to possibly warn against inconsistencies, there's an option for that, and that's called with raw types. So in this case, what we do is we use our helper again with raw types. The compiler won't actually raise any exceptions or any compiler errors, and Coherence won't actually raise any exceptions. It will just log if your types don't match, and that is compared against your cache configuration. The problem and the big challenge here is that because we're no longer performing type checking and all of these types here are erased at runtime, you can actually, regardless of what you declare here, place different types of value in a cache. Technically speaking, this is no difference from the polymorphism that Coherence already offers with name cache. But it should be noted, just by putting these types in here, declaring your variables as these types, and using raw types is not enough to ensure any type safety at all. So if this is sort of bad, why would you do this? Well, imagine you're migrating an existing system to use generics. This may be your first step. You want to start using generics in your application, but you don't want to change your cache configurations. So you can do this very simple change in get type cache with this one parameter, and now you can start using name caches with generics. Of course, you've not increased your type safety, but you can remove all of those casts that we were talking about. So, what happens when an application assigns the same name cache to different variables with different mappings? Well, it's quite clear. Java will completely allow this to happen, so you need to be careful. The only way to prevent this is to actually say use with types, or if you just want a warning, then you can declare the types in your cache configuration. The weakest approach is to completely turn off type checking altogether. To do this, you do this when you want to use generics but have no intention to declare the types, and you're basically saying to Coherence, look, I know what I'm doing, I'm going to look after the types, don't ever warn me. So again, we use one of our helpers, we say type assertion without type checking. So the intent is very clear in your application. You can in fact search for these things and say, well, hey, where have I decided not to use type checking? So it makes it very clear the intent as to what you want to achieve. And as before, Coherence can't perform any checking, Java won't perform any checking. You get the benefit of using generics, the benefit of removing casts, but essentially there's nothing happening underneath. What happens when an application does this? Well, nothing at all. This is completely legal, and basically it's up to you to manage types. Let's talk about backwards compatibility. So to maintain existing compatibility with existing applications that say are using Coherence, specifically the existing get cache method, the signature has been changed to return a name cache of object, because that is essentially what it is. All existing applications that use name cache are actually using it in this form. So we made this change, and this importantly prevents anyone accidentally using generics by calling get cache. The compiler will issue a compile time error, and if you really want to circumvent this, then you'll have to write a manual cast, and it basically will give you a hint as to what you need to do. And if you're tempted to use a cast, then obviously you should start to use get type cache. Internally, this call is actually semantically equivalent to calling get type cache with raw types, and of course when you haven't declared the types in your cache configuration. So, although Coherence provides multiple options for type safety when requesting caches, due to the erasure nature of the Java programming language, we really can't enforce that many things without checking every single key and value type at runtime, which could be very expensive. So it's possible for each of these following statements to occur, and that are compile time safe and are perfectly legal, but you can see that they have very different meanings at runtime. So depending on how you've configured your caches, Coherence can actually warn against these sorts of problems if you choose to configure them that way. Later, we plan on actually introducing further type safety through the use of type assertions, and that will actually help prevent and protect developers from possibly having different types of values in caches where they want strong type safety. So which one should you use? We've showed three options for type safety, and basically you can make the decision. Essentially you have to decide if you want to use name cache or name cache with key and values. If you just want to use name cache, then continue using cachefactory.getCache, and don't bother to declare the types in your configuration. If you want to use generics, then really the next question is, do you want type safety in terms of compile time type safety? And if so, then you should look at using get type cache and use with types and declare the types in your configuration. And this gives you basically compile time and runtime type safety. If you don't care about compile time safety so much, but instead you just want warnings if there are inconsistencies in between types, where it's declared, and what's in your configuration, then you can say get type cache and say use raw types. And if you really don't care at all, you just want to use generics and you don't care about configuring them and you have no intent on configuring them, then you can just say, look, without type checking. So in this session, we looked at how to use the new parameterized name cache interface. We discussed the concept of type safety and how it can be improved or, in fact, disabled when required. While seemingly this is a pretty small feature, adding generics to coherence was a pretty big effort. And this improvement has actually the foundation of many new features that you'll see inside of Coherence 12.2.1. For example, the ability to use things like lambda expressions and stream-based processing, and most of the Java 8 compatibility stuff that we added. I hope you found this session useful. Next up, I would recommend that you take a look at the lambda and stream videos in this series. All of those essentially leverage what we've just talked about. Thanks for your time.